Hi everyone, I welcome you to the presentation on solar technology. Basically what we'll cover in this presentation is we are going to cover how solar panels generate electricity from the sun. And then once that electricity is generated, it's supposed to be stored in a storage capacity which we are calling a battery. Okay, so we'll be generating electricity. Once we generate it, we need to keep it, we store it. So we'll be using batteries for storage. And then these batteries have to be monitored. As we are generating that electricity, trying to charge the batteries, we're supposed to monitor the battery when it's full. So you can't manage to do that physically. We'll be using a device which we are calling a charge controller. It will be basically be controlling the amount of electricity charging the battery. Okay, and then once that electricity is generated, which is DC in nature, for us to use for home consumption, we use AC. So we'll be using a device called an inverter, which will be converting the DC electricity we are generating from the sun to AC. So basically this is the whole cycle for solar technology. So you need to know how many panels you need to put in your installation. For batteries, you need to size them, charge controller, including the inverter. So we'll have a series of 4 videos for this presentation where we'll look at PV sizing, which is the sizing of the solar panel, sizing of the batteries, sizing of the charge controller, as well as sizing of the inverter. Okay, so we'll start with sizing of the solar panels, which are photovoltaic. Okay, so when you want to make when you want to generate electricity using solar panels, you need to know how many do you need to use in your installation. Okay, so the first step in designing a PV, which is a photovoltaic system, is to determine or to find out the total consumption that needs to be powered by the PV. So you need to know the requirement of a house, for example. What is the load capacity? And then once the total load on the system is known, then the PV system can be designed. Okay, so we shall take the following steps in determining the size of the PV, which are the panels. So number one, you need to determine the power consumption demands. So how we determine that is we carry out a load analysis, which should be in watt hours. Once we have that, you also put a tolerance of 30% of that same watt hours. So you carry out a watt hour configuration. I'll show you how to do that, and then just add 30% of that to the whole system just to compensate on the losses. And then sizing of the PV is given by this formula. So we'll be sizing our panels by this. Number of PV panels required is given by the PV capacity divided by the maximum power of the panels. Okay, where the PV capacity there is basically the total daily power consumption plus 30% of this same total daily power consumption, and then you divide that by perfect sun hours. These perfect sun hours, this is information which is on the internet. You can just check. Every place has got its own perfect sun hours, as shown on the next slide. So this is a solar resource map for Zambia. It's showing values for the perfect sun hours for different locations. For example, Lusaka, as you can see that color, it's somewhere there, which is about 5.5. So each place has got its own, but on average Zambia is given 5.5 somewhere there. But for Lusaka, to be specific, if you use the resource solar map, Lusaka, that color, it's 5.5 there. So an example, the house below built in Lusaka has the following daily power consumption. So this is a house, the location is Lusaka. So the reason for us knowing the location is just to know the perfect sun hours for that location. Okay, so this house has got the following consumptions. It's got a heater which has a wattage of 250 watts. You're using it for 8 hours. It's got 5 lamps which have got a wattage of 60 watts. You're using them for 12 hours. It has one refrigerator, wattage of 150 watts. You're using it for 12 hours. And it has a TV which has a wattage of 200 watts, and then you're using it for 6 hours. Question is, how many panels of wattage 100 watts are needed for the PV solar installation? And then B part of that question, how many panels of wattage 200 watts will you need? So for you to determine this, okay, so on our solution, we are saying number of PV panels required for PV installation is given by PV capacity, divide that by the maximum power of the panels, where the PV capacity is basically total power daily consumption plus 30% of that same, then you divide that by the perfect sun hours. Since our house is in Lusaka, perfect sun hours we are going to use 5.5 according to our solar resource map. And then total daily power consumption will do a load analysis. Okay, so the total daily power consumption, which is basically this, is simply we have loads there, wattage, hours, as well as the watt hours. So for the load heater, we've got 1, so it will be the wattage of the heater times the duration of the heater. You multiply that, it will give you that as the total watt hours. It will be the same for the TV and the refrigerator, except for lamps, because the quantity here it's 5. So the total watt hours for lamps, it will be 5 times the 60 watts times the duration, which is 12, and that will give us that. Once you have those watt hours for respective loads, then you add them together, you are going to have this as your total watt hours. Okay, so when you come to PV capacity there, which is basically total daily power consumption plus 30% of that divided by perfect sun hours. So our total daily power consumption is this, which is 8,600. It's the one we are having there, and then we are adding 30% of that to compensate on the losses, which is 30% of 8,600. Whatever you have there, you divide by the perfect sun hours according to the solar resource map for Lusaka, which is approximately 5.5. So that figure divided by 5.5, you are going to have 2032. Okay, so for us to determine the number of panels, it will basically be PV capacity, which is this 2032, and then you divide by the maximum power of the panels. So for the A part of the question, the maximum power, they said we use 100 watt panels, so you put 100 there. When you divide that, you are going to get approximately 20 panels. Okay, you can try the B part of the question by dividing by 200. Okay, so in the next presentation we are going to look at battery sizing.